Happy morning, students. I am your physical science teacher. In our today's class, we are going to start a new lesson, Unit 6 Nuclear Physics. In this lesson, we are going to learn what is radioactivity, properties of alpha, beta, and gamma rays, and uses of radioactivity and few more topics in this lesson. Come, let's move on to the video session. Children, already we learnt what is atom and structure of atom, everything. Okay, you know already that atom is a very tiniest particle. Further, we cannot divide it into two. That is what called as atom. So, you know the structure of atom. It has the particle, protons, neutrons and electrons. Protons and neutrons always located in the nucleus, that is the center of the nucleus. Okay, and the electrons is always revolve around the nucleus. So proton is a positively charged particle, neutron is a chargeless neutral, both are located in the nucleus, and the electron is negatively charged particles. It is always revolve around the nucleus. This is the structure of atom. Radioactivity. Discovery of radioactivity. In the year 1896, French physicist Henri Becquerel finished his research for the week and stored a certain amount of uranium compound away in a drawer for the weekend. By chance, an unexposed photographic plate was also stored in the same drawer. After a week, he returned and noticed that the film had been exposed to some radiation. So, he discovered that he could reproduce the effect whenever he placed uranium near a photographic plate. Apparently, uranium radiated something that could affect a photographic plate. So, this phenomena was called as radioactivity, and uranium was identified to be a radioactive element. 2 years later, the Polish physicist Marie Curie and her husband Pierre Curie detected radioactivity in pitchblende as a tiny black substance. They were not surprised at the radioactivity of pitchblende, which is known as an ore of uranium. Later, they discovered that the radiation was more intense, means very powerful, from pure uranium. Also, it was found that the pitchblende had less concentration of uranium. They concluded that some other substance was present in pitchblende. After separating this new substance, they discovered that it had unknown chemical properties and it also emitted radiations spontaneously like uranium. They named this new substance as radium. The radioactive elements emit harmful radioactive radiations like alpha rays or beta rays or gamma rays. Definition of radioactivity. We already learnt that stable electronic configuration and unstable electronic configuration in the class 9. Okay, when we will say stable electronic configuration, in the outermost shell 8 electrons will be there. Okay, so if there is less than 8 electrons, we will say it is called as unstable electronic configuration. So such nuclei undergo nuclear decay and get converted into more stable nuclei. Okay, during this nuclear reaction, these nuclei emit certain harmful radiations and elementary particles. The phenomena of nuclear decay of certain elements with the emission of radiations. What radiations? Like alpha, beta, and gamma rays. This is called radioactivity, and the elements which undergo this phenomenon are called radioactive elements. Here you can see this picture. First one alpha rays, second one beta rays, third one is the gamma rays. Here, which is more penetrating power? You can see gamma rays is the more penetrating power and alpha rays is the very less penetrating power. So by using paper, you can see this alpha rays, by using paper or skin we can stop the alpha rays. And you see the second one, by using aluminum we can able to stop the beta rays. The last one, third one is the gamma rays. By using this lead container to stop the gamma rays. Okay, so which is more penetrating power? Means gamma rays. Next one is the natural radioactivity. The elements such as uranium and radium undergo radioactivity and emit the radiations on their own without any human intervention. This phenomenon of spontaneous emission of radiation from certain elements on their own is called natural radioactivity. Let us see what are the elements which undergo into the radioactivity process. The elements whose atomic number is more than 82 undergo spontaneous radioactivity. Example, uranium, radium, etc. There are only two elements which have been identified as radioactive substances with atomic number less than 82. They are, you can see this picture, they are technetium with atomic number 43 and promethium with atomic number 61. Next one is artificial radioactivity or induced radioactivity. The phenomenon by which even light elements are made radioactive by artificial or induced methods is called artificial radioactivity or man-made radioactivity. Artificial radioactivity is induced in certain lighter elements like boron, aluminum, etc. by bombarding them with radiation such as alpha particles emitted during the natural radioactivity of uranium. During such disintegration, the nucleus which undergoes disintegration is called parent nucleus, and that which is produced after the disintegration is called daughter nucleus. This kind of radioactivity was discovered by Irene Curie and Joliet in the year 1934. The particle which is used to induce the artificial disintegration is termed as projectile. The particle which is proposed after the disintegration is termed as ejected particle. Already I told you that disintegration means in this process the nucleus will break into the small pieces. Okay, so before disintegration is termed as projectile, and after disintegration is termed as ejected particle. When the projector hits the parent nucleus, it is converted into an unstable nucleus, which in turn decays spontaneously, emitting the daughter nucleus along with an ejected particles. Next, let us see how the disintegration process is happening through the activity. If you denote the parent and daughter nuclei as X and Y respectively, let us see the example 4Be9. What is Be? Is beryllium element. The atomic number is 4 and the mass number is 9 here, plus 2He4. What is He here? He means helium element. Atomic number is 2 and the mass number is 4, which gives 6C13. C means carbon. Actually, what happens in the above nuclear reactions? 6C13 is unstable and is radioactive. So this reaction can be represented as 4Be9 plus 2He4, which gives a 6C12 plus ON1. That means He. This helium is the induced artificial integration as the projectile. So which gives 6C12, and it is unstable, and the ejecting is the neutron 0N1. Okay. Comparison between natural and artificial radioactivity. First point, emission of radiation due to self-disintegration of a nucleus. For artificial radioactivity, emission of radiation due to disintegration of a nucleus through induced process, that is man-made process. Second one, alpha, beta and gamma radiations are emitted. In this natural radioactivity, for artificial, mostly elementary particles such as neutron, positron, etc. are emitted. For natural radioactivity, it is a spontaneous process. For artificial, it is an induced process. Natural radioactivity exhibited by elements with atomic number more than 83. Here, exhibited by elements with atomic number less than 83. Natural radioactivity cannot be controlled. Artificial radioactivity can be controlled. Units of radioactivity. It is the traditional unit of radioactivity as defined as the quantity of radioactive substance which undergoes 3.7 into 10 to the power 10 disintegrations in 1 second. 1 Curie is equal to 3.7 into 10 to the power 10 disintegration per second. SI unit is becquerel. 1 becquerel is equal to 1 radioactive decay per second, that is equal to 2.703 into 10 to the power minus 11. Another unit of radioactivity, Rontgen, is unit of X-ray or gamma ray and cannot be used for other ionizing radiation like beta ray or neutron. For these, an additional unit, the rad, was introduced in 1956. Next, in 1962, it was decided Rontgen is the unit of exposure. Rad unit is the unit of absorbed dose. That is 1 Rontgen is equal to 2.58 into 10 to the power minus 4 coulomb per kilogram of air. Next, alpha, beta and gamma rays. When a radioactive nucleus undergoes radioactivity, it emits harmful radiations. These radiations are usually composed of any of the three types of particles. They are alpha, beta and gamma rays. Next, see the properties of alpha, beta and gamma rays. Here, three particles possesses certain similarities and dissimilarities in their properties are listed in this tabular column. First one, properties. What are they? Alpha rays, helium nucleus 2 He power 4 consisting of 2 protons and 2 neutrons. Beta rays, they are electrons 1 minus 1 e power 0, basic elementary particle in all atoms. Gamma rays, they are electromagnetic waves consisting of photons. Next property is the charge. Alpha rays, it is a positively charged particles. Charge of each alpha particles is equal to plus 2e. Beta rays, it is a negatively charged particles. Charge of each beta particle is equal to minus e. Gamma rays, it's a neutral particles. Charge of each gamma particle is equal to 0. Next property is the ionizing power. For gamma ray, alpha rays, 100 times greater than beta rays and 10,000 times greater than gamma rays. For beta rays, it is a comparatively low. For gamma rays, very less ionization power. Next property is the penetrating power. For alpha particles, low penetrating power even stopped by a thick paper. For beta rays, penetrating power is greater than that of alpha rays. They can penetrate through a thin metal fossil. For gamma rays, they have a very high penetrating power, greater than that of beta rays. They can penetrate through thick metal blocks. Next property, effect of electric and magnetic field. Alpha rays deflected by both the fields in accordance with Fleming's left hand rule. For beta rays deflected by both the fields, but the direction of deflection is opposite to that for alpha rays in accordance with the Fleming's left hand rule. Next, for gamma rays, they are not deflected by both the fields. Next property, speed. For alpha rays, their speed ranges from 1 by 10 to 1 by 20 times the speed of light. For beta rays, their speed can go up to 9 by 10 times the speed of light. For gamma rays, they travel with the speed of light. It travels equally to the speed of light.